quick video just explaining how the rotary motion sensor works. We see we have a plate on top of here that's free to spin, and there's a little bit of friction, but it's not too crazy. And what we're going to do is I'm going to spin this thing, and let me show you the settings on here really quick. Just a second. So it looks like we're set in degrees per second, just to make you have to do a little bit of calculation. Now, when you look at a standard math coordinate system, you're used to thinking this is positive theta and this is negative. Right now, this is set up the same way as that. So this is going to be a positive, and this is going to be a negative. And what we can do is, oops, let me get my graph back. I lost it. All right, so what I'm going to do is start spinning this thing. Whoops. And I'll show you the graph. And so you can see this thing is spinning at about 2,500 degrees per second. I'm going to put my finger on it, and that should slow it down. And I'm going to go ahead and stop it there. And I'm going to pause for a second. You keep running. And so notice, here was there was a little bit of friction, so it's slowing down a little bit. And then when I put my finger on it, it slowed down a lot. And one last thing that we can do with this, I can use this XY mode. And notice if I put the cursor right here, hopefully you can see this number. It's XY, so in this case, X is going to be the time in units of seconds. And up here, we've got angular velocity, not angle, angular velocity in degrees per second. So notice you can look at these points and you can try and estimate. So right there at 9.25, you get 1420. Whoops, that's not what I wanted to do. But I guess, yeah, that's fine. And then over here at 6.8, you can see it's 21.80. And actually you can get a rise and a run there, it looks like. But in any event, from this information, hopefully you could figure out whatever we need for lab today. That's it.